Today's lesson is reducing fractions, or finding the simplest way to represent a fraction. One strategy that will work is the greatest common factor, or the largest number that both the numerator and the denominator can be divided by. The steps are as follows. We need to list the factors of each number. And in this case, the numerator 8, the factors are 1 and 8, 2 and 4. The factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So I see that the largest factor that they have in common is 4. So what I'll do then is take my 8/12 and divide the top and bottom by 4, getting my answer of 2/3. 2/3 is 8/12 reduced using the greatest common factor. Now this strategy works all of the time, every time, if you know your basic facts and you know how to determine all of the factors of a number. The other strategies I'm going to show you deal with easier or shortcuts that you can use to determine your reduced fractions. Even numbers, cut them in half. If both your numerator and denominator are even, you can simply cut them in half until either the numerator or the denominator or both is an odd number. So in this example, I can cut 10 and 12 in half and get 5/6. Now in this case, it is reduced. I do end up with an odd number on the top and an even number on the bottom, so I can no longer continue to cut things in half. But it doesn't always work that way. In this example with 16/24, I can cut the 16 in half and get 8, and cut the 24 in half and get 12. Now they're both still even, so I can continue to cut them in half. Half of 8 is 4, half of 12 is 6. Notice they're still even. I can continue to cut them in half. Half of 4 is 2, half of 6 is 3. Now I need to stop right here because my denominator is odd. As soon as I reach an odd number, I need to stop cutting things in half. So the simplest fraction for 16/24 is 2/3. Here's an example, 12/18, where it doesn't quite work out the way we might think. They're both even, so I can continue to cut them in half. Half of 12 is 6, and half of 18 is 9. But in this example, 6/9 is not a reduced fraction. It's not reduced to lowest terms. If I look at both of them, the 6 and the 9, I can see that 3 can go into them evenly. That's why we have the very next strategy. This strategy is appropriately called try to divide by 3. Try this step after using the cutting in half strategy just in case. And so here's our example of 6/9. Well, I can't cut them in half because 9 is odd, but 6 is even. So I can try dividing the top and bottom by 3. And when I do that, I end up with a reduced fraction of 2/3. That is the final answer to 6/9 reduced. So try dividing by 3 if you are done completing the cutting in half step, or if you see that both the numerator and the denominator are divisible by 3. The next strategy is called top into bottom. If the numerator goes into the denominator evenly, you are done looking for your greatest common factor. In fact, it's looking at you as you are trying to do the problem. In this example, 7 goes into 21 evenly. In other words, if I skip count by 7, I'll eventually get to 21. In this case, 7 is the greatest common factor. So all I need to do then is to divide the top and the bottom by 7. I will end up with a reduced fraction of 1/3. Another example of top and to bottom is if you have 8 24ths. Since 24 is a multiple of 8, 8 is my greatest common factor. All I need to do is divide the top and the bottom by 8, and I end up with 1/3 again. And that is how you use the top and to bottom strategy. So how do I know if my fractions are reduced? How do I know if a fraction I'm looking at is already reduced? And how do I know if, when I'm reducing fractions, if the answer I get is reduced? So we're going to take a look at these next 3 situations, and that'll help us figure it out. In this case, if the numerator is 1, your fraction is done. For example, if I have 1/10, that's as few of the pieces that I can have. I have 1 piece out of 10. I can't have fewer than that and still equal 1 piece out of 10. Same holds true if I have 1/6 or 1/51. All of those fractions are the smallest and simplest way of representing that fraction. So if the numerator is 1, your fraction is done. If the denominator is prime, your fraction is fine. So if I have 6/7, 7 is a prime number, I don't have any other common factor other than 1 between 6 and 7, so that's reduced. Same holds true with 8/23. The denominator is prime, I cannot reduce that fraction. The last one to recognize is if the numerator is 1 away, your fraction is okay. Now, if I have 5/6, the numerator is 1 away from having the whole thing. I'm 1 piece away, and that is already reduced. I can't express that fraction in any other way, in any other simplest way. So anytime that my numerator is 1 away from the denominator, 1 less than the denominator, that fraction is reduced. So all of these fractions are reduced to lowest terms. That's how we reduce fractions in Mr. Naffy's class. Good luck on your assignment. Do your best.